Section 8.4 is about this thing we talked about a little bit in previous sections, but the determinant of a square matrix. So every square matrix can be associated with a real number, and we call it its determinant. Let me switch to a thinner writing tool. I was using way too thick of a pen. Determinant. So this real number has two uses. The first is determining whether or not a matrix in question has an inverse, and also other stuff, which we're going to worry about later. So let's take a look at an example of what this looks like. We've actually kind of done this before. So here's matrix A. Matrix A is going to be some notation. We got A1, B1, A2, B2. And then for the determinant, we're going to use the notation det of A. And we're going to also kind of make it look like an absolute value. So we're going to say the absolute value or determinant of A. And we're also going to make essentially the same matrix, but instead of a squared off bracket, we're just going to have those straight lines. So we got A1, B1, A2, B2. Now, the way we calculate it is something we actually did already. The way we calculate it is going to be A1 times B2 minus A2 times B1. In the previous section, when we were looking at inverses, we referred to it as like A times D minus B times C. That's format. So it's the same order, just using slightly different letters. So we're asked to find the determinant of these matrices here. So for matrix A here, the determinant we're going to do, let me switch back to a writing tool. Determinant of A is equal to, again, using the diagonal. So we got 2 times 2 minus, and then switch colors, highlighting those two colors, minus 1 times negative 3. Cleaning this up a little bit, we got 4. 1 times negative 3 is negative 3, so minus negative 3 is the same as plus 3, which gives us 7. Doing the same thing over here, determinant of B, we're going to do 2 times 2 again, so the top right and the bottom left, so the top left and bottom right, minus 4 times 1. So we end up with 4 minus 4, which is 0. Now what that tells us is that B has no inverse. In other words, we call it singular. We talked about that a little bit in section 8.3. Pause the video and try matrix C on your own, and then when you're done, come back, and clearly you paused, we're back, so we got determinant of matrix C equals, we got 0 times 4 minus 2 times 3 over 2. We end up with 0 minus 3, which is negative 3. So unlike some other examples, you are allowed to have negatives for our determinant for matrices.